Bismillahirrahmanirrahim. This is the fifth part of this topic, inverse trigonometric function. In this part, I'm going to give more examples or exercises how to find the exact value for the inverse trigonometric functions. In this set, we need to find the exact value of cosine 2 sine inverse square root of 2 divided by 2. And the second exercise will be to find the tangent of 2 sine inverse square root of 3 divided by 2. And also we are going to have different type of exercises where we are going to apply either the double angle or sum of the two angles, or maybe difference between two angles also. Now the first exercise 51, we need to find the exact value of cosine of 2 sine inverse square root of 2 divided by 2. So let's think about sine inverse of square root of 2 divided by 2. Take it as a part. We know that sine inverse of square root of 2 divided by 2 equal to, since we have positive value, this will be in the first quadrant, or it will be less than pi over 2. Because the domain of sine inverse is between -1 to 1, and the range is the domain equal to -1 to 1, and the range is minus pi over 2 to pi over 2. And since we have positive square root of 2 divided by 2, so it will be a positive angle. And this is equal to 45 or pi over 4. We know that sine inverse of square root of 2 over 2 equal to pi over 4. So cosine of 2 sine inverse can be written as cosine of 2 multiplied by sine inverse will give me pi over 4. So it is cosine of pi over 2, or 90 degrees. Cosine pi over 2 equal to 0. So the first one, 51, give me 0. The second one, tangent of 2 sine inverse square root of 3 divided by 2. And we know that sine inverse of square root of 3 divided by 2 equal to 60 degrees, or it's equal to pi over 3. So the tangent now can be written as tangent of 2 multiplied by 60 or pi over 3. This will be equal to tangent of 2 or 101. This is what I can write it as 120 or 2 pi over 3. This is in the second quadrant. We know that the 120 is in the second quadrant, which means the tangent is negative. So this can be written as minus tangent of 60. Minus tangent of 60, which is equal to square root of the opposite divided by the adjacent. This is equal to minus square root of 3. So it is minus square root of 3. Next one, number 15. Or I will start with 54, then I will use or leave the 56 to the end. Number 54. Cosine of 2 tangent inverse of 1. Now tangent inverse of 1 is equal to 45. So this can be written as cosine of 2 multiplied by tan inverse will give me 41, or I'm sorry, 45. So it's equal to cosine of 90, which is equal to 0. So cosine of 2 tangent inverse, that will be cosine of 2 multiplied by 45, which is equal to cosine of 90 degrees. That will give me 0. Now for the last one, which is equal to question number 53. Sine of 2 sine inverse 4 over 5. Sine, this is 53. And to find sine of 2 sine inverse, it is 4 over 5. For this one, I will say let sine inverse 4 over 5 equal to theta. This will give me sine theta equal to 4 over 5 by the definition of the inverse trigonometric function. So this one now, this will give me sine of 2 multiplied by theta. It is 2 sine or sine 2 theta. So I'm going to use the double angle identity. This will give me 2 by the double angle identity. This is equal to 2 sine theta cosine theta. Sine theta is already there given. I need to find cosine theta. But we know that sine theta is equal to y over r. So x will be equal to square root of r squared minus y squared, which is equal to 25 minus 16 is equal to square root of 9, which is equal to 3. This is x. So cosine theta, which is equal to x over r, I will have 2 multiplied by sine. Sine theta is given by 4 over 5 multiplied by cosine theta. Cosine theta is equal to x over r. And x equal to 3 divided by r, which is equal to 5. That is 2 multiplied by sine theta, cosine theta. This will be 24 over 25. So sine of 2 sine inverse 4 over 5 is equal to 24 over 25. The idea is to find sine theta, from which we can find x, and that will give me cosine theta, which is equal to 3 over 5. Then apply the double angle identity. See question number 55. We need to find sine of sine inverse 2 over 3 plus cosine inverse 1 over 2. So for question number 55, let sine inverse 2 over 3 equal to theta. This will give me theta equal to, or cosine sine theta equal to 2 over 3. And this is in the first quadrant, actually, because this is positive. Since it is positive, it will be in the first quadrant. So I have y and I have r equal to 3, y equal to 2. From this one, I will have x will give me 9 minus 4, which is equal to square root of 5. This will be x. For the second one, okay, from this one I can find also cosine theta. This will give me cosine now. Theta, that will be x over r, that will be square root of 5 divided by 3. For the second part, I will say that cosine inverse equal to theta, or just we can find it also, this one. Cosine inverse 1 over 2 is equal to 60. We know it is equal to 60. Now, using the sum of the two angles identity, I will have sine of sine inverse 2 over 3 plus cosine inverse 1/2 can be written as sine. For the first one, sine inverse 2 over 3, we said it is equal to theta, plus the second one, this one will give me 60. So I have identity of sum of two angles. So I will have sine theta multiplied by cosine 60 plus cosine theta multiplied by cosine of 60. Again, we say sine inverse will equal to theta. Cosine inverse will give me 60. Then I will have sine theta plus 60, and this is sine of alpha plus beta, or sum of two angles, which is equal to sine alpha cosine beta plus cosine alpha sine beta. So it is sine theta multiplied by cosine 60 plus cosine theta multiplied by cosine 60. I applied this identity, sine alpha plus beta equal to sine alpha cosine beta plus cosine alpha sine beta, where beta equal to 60 in this case. Now we have sine theta given there. It is 2 over 3. This is sine beta. So I have 2 over 3 multiplied by cosine 60, which is equal to 1/2, plus cosine alpha, or cosine theta, which is equal to square root of 5 divided by 3. So it's equal to 5 divided by 3, multiplied by, so this should be sine, not cosine. So sine 60, which is equal to square root of 3 divided by 2. So I will have 2 over 6 plus square root of 15 all to power, all divided by 6. So it is 2 multiplied by 1 equal to 2. And square root of 5 multiplied by square root of 3 equal to square root of 15 divided by 3 multiplied by 2, which is equal to 6. So it is 2 plus square root of 15 plus, so 2 plus square root of 15 divided by 6. Similarly, we can find the value for question number 56, which is cosine sine inverse 3 over 4 cosine inverse 5 over 13. Number 56. Let's find cosine of sine inverse of 3 over 4 plus cosine inverse of, that is 5 over 13. I can use the sum of two angles identities. This will give me, I can write it as cosine of alpha plus beta, where sine alpha or sine inverse 3 over 4 equal to alpha. This will give me sine alpha equal to 3 over 4, which is positive in the first quadrant. This is 4. 3. Then I will have square root of 7 there. This is 4 square 16 minus 9 equals square root of 7, from which I can find cosine alpha, which is equal to square root of 7 divided by 4. This is for the first part. And beta equal to cosine inverse 5 over 13. I will call it beta. This will give me cosine beta equal to 5 over 13. Again, this is also in the first quadrant because it is positive. I have 5 for x, for the hypotenuse equal to 13, and for the y, I will have square root of 144, or it is equal to 12. This is x over r. Y can be written as square root of 116, 13 square minus 25 equal to 144, which is equal to 12. So sine beta is equal to 12 over 13. So now I have sine alpha, cosine beta, and sine beta. So cosine alpha plus beta, this one now, equal to cosine alpha, cosine beta, minus sine alpha, sine beta, which is equal to cosine alpha equal to square root of 7 divided by 4. Cosine beta, this is equal to 5 over 13 minus sine alpha, go back, it is 3 over 4, multiplied by cosine beta or sine beta, that is 12 over 13. This will give me square root of 7 times 5. This will give me 5 square root of 7 minus 36 divided by 4 times 13, which is equal to 52. So it is 5 square root of 7 minus 37 divided by 52. This is the value of cosine of sine inverse 3 over 4 plus cosine inverse 5 over 13.